Nobody warned them about the silence. They trained for 2 years. They rehearsed every alarm. They memorized the sound of every fan, every valve, every pump inside that cabin. They were told exactly what zero gravity would feel like in their bodies. They were told exactly how the food would taste. They were told how their eyes would water from the recycled air and how their muscles would ache from floating without gravity to push against. Nobody told them what it would sound like when the ship spoke, and it did. In the dark, 200,000 miles from Earth, in a pressurized metal capsule moving at 12,000 kilometers per hour through a vacuum that should contain no sound at all. The wall knocked. This is the part of spaceflight that never makes the news. Not the launch, not the lunar flyby, not the splashdown. The 3 seconds at 2 in the morning when a trained astronaut, surrounded by silence, heard something on the other side of the hull and stopped breathing. This is that story. Let us start with what we think we know. Space is silent. You have heard this your entire life. In the vacuum between planets, there is no air, no medium for vibration. Sound requires molecules to travel through. And out there, the molecules are so far apart that for all practical purposes, they do not exist. A star could explode 3 kilometers from your window in deep space, and you would hear nothing. Absolutely nothing. This is true. But here is what nobody tells you. You are not in space. You are in a spacecraft. And a spacecraft is not empty. It is not silent. It is not dead. A spacecraft is a pressurized metal tube filled with air, with machinery, with pumps and fans and gyroscopes and valves, all of them cycling on schedules that the crew does not always know in advance. The walls of that tube are thin. At their thinnest, the pressure boundary between a living astronaut and the vacuum outside is measured in centimeters, not feet, not meters. Centimeters. On one side, a human being, breathing, sleeping, floating. On the other, a vacuum cold enough to freeze your skin in seconds and radiation strong enough to damage your DNA through the wall. And that thin layer of metal between them? It talks. It expands when sunlight hits it. It contracts when it rotates into shadow. Every 90 minutes on the International Space Station, every cycle of light and dark, the metal hull goes through a temperature swing of 250 degrees Celsius. It does not do this smoothly. It does it in small, sudden releases, like ice cracking on a frozen lake. Each release sends a vibration through the entire structure. Every bolt, every panel, every weld joint transmits it, and the crew, floating inside their pressurized pocket of air, hears it as a sound. A knock, a tap, a pop from somewhere in the wall. This is the first thing every astronaut learns in space that nobody could fully teach them on the ground. The ship is alive, and it has its own language. The first person to understand this was probably Yuri Gagarin. April 1961. 108 minutes in orbit. He reported that the spacecraft made sounds he did not expect. He did not elaborate. He was not asked to. The program moved forward. For the next 4 decades, astronauts and cosmonauts accumulated an informal library of unexplained sounds in space. A library nobody published. A library passed down the way all uncomfortable knowledge gets passed down. By word of mouth, just before launch, in quiet hallways. You will hear things. Do not panic. It is probably nothing. probably. Go forward to October 2003. China is launching its first taikonaut, a fighter pilot named Yang Liwei, alone in a single-seat capsule called Shenzhou 5. The weight of an entire nation's space program on his shoulders. He cannot afford to fail. He cannot afford to panic. He cannot afford to be anything other than perfectly controlled, perfectly professional. He completes his first orbit. Then he hears it. A knocking. Slow, hollow, deliberate. He described it years later as the sound of someone striking the outside of a metal bucket with a wooden mallet. He searched the porthole. He checked the panels he could reach. He found nothing. And then he made the decision that every astronaut before and after him has had to make at some point. He decided it was not worth stopping for. He decided it was normal. He flew the remaining 13 orbits with the sound as his only company. He returned to Earth a national hero. He told the story at a press conference. The Chinese space program took it seriously enough that every subsequent Shenzhou crew was briefed before launch. The language of that briefing, as reported years later, was careful. You may hear a knocking sound during your mission. We believe it is normal. We believe. They were not certain. They are still not certain. Go back to 1969. Apollo 10. The full dress rehearsal for the moon landing. Tom Stafford, John Young, Gene Cernan fly the lunar module to within 15 kilometers of the lunar surface, and then fly back up to rejoin the command module. As they pass behind the moon, completely cut off from Earth, no radio contact, the most isolated 3 human beings in history at that moment, their communication system picks up a sound, a whistling. They describe it on the recording as outer space music. The transcript survives. Cernan says, "That music even sounds outer spacey, doesn't it?" Young says, "You hear that? That whistling sound?" Stafford says, "Yes." They are clearly unsettled. They are equally clearly trying not to be. NASA classified those recordings for decades. When the audio was finally released in 2016, engineers offered an explanation. Radio frequency interference between the 2 spacecraft's communication systems operating at close frequencies, producing a beat pattern. A clean explanation, possibly correct. But the astronauts behind the moon, cut off from every human voice, hearing music from nowhere, did not have that explanation. They just had the sound. And the 45 minutes until Earth came back. To understand why these sounds matter, you have to understand the environment. Not the mathematics of it, the experience of it. Imagine a room the size of a large minivan. Now imagine you cannot leave that room for 10 days. Now imagine the room is surrounded, on every side, by the most hostile environment in the known universe. Now imagine the walls are the thickness of a few centimeters of aluminum and composite material. And now imagine that every 24 hours you are expected to sleep in that room. Not in a bed in the corner, behind a closed door, with traffic noise and neighbor noise and all the sounds of a living city telling your brain that everything is normal and the world is still there. In a sleeping bag attached to a wall, in a room where the fans never stop and the machinery never stops, and the darkness outside the small round window is absolute. This is the environment in which the Artemis II crew spent 10 days in April of 2026. Their capsule was named Integrity. 4 people: Reed Wiseman, Victor Glover, Christina Koch, Jeremy Hansen. The 4 of them had logged hundreds of hours in simulators, in training, in zero-gravity aircraft, in underwater EVA practice. None of that prepared them for the sound. NASA does not publicize the details of what exactly the Artemis II crew heard, or when, or how many times. What we know is this. At some point between Flight Day 3 and Flight Day 10, at least one member of the crew heard something in the wall. Something that did not match the briefing. Something that made all 4 of them stop what they were doing and listen. Not to mission control, not to each other, to the wall. Because the wall had spoken first. So what is the ship saying? The engineers have 3 answers. They will give you all 3, and they will not tell you which one applies to the sound that woke you up. The first answer is thermal. Metal expands when it is hot and contracts when it is cold. In space, this happens violently. The difference between the sunlit side of a spacecraft and its shadow side can be 250 degrees in a single rotation. The metal does not move gradually. It moves in tiny, sudden jumps, each one releasing stored stress. Each jump makes a sound, like a rifle shot in slow motion, transmitted through your bones via the hull. Engineers have known this for 60 years. They designed spacecraft to tolerate it. They warn every crew. And still, every single crew hears it at 3 in the morning and freezes. Because the human brain did not evolve in space. It evolved in forests. And in forests, a knocking in the dark meant one thing. Something was trying to get in. The second answer is smaller. Much smaller. The space between Earth and the Moon is not empty. It looks empty. It feels empty. But it is filled with a fine, invisible sleet of particles. Dust grains from ancient asteroids, fragments of comet tails, microscopic chips of rock that the Moon threw off its own surface billions of years ago when larger rocks hit it. Most of these particles are smaller than a grain of sand. All of them are moving at 10, 15, 20 kilometers per second. When a particle the size of a poppy seed hits a spacecraft hull at that velocity, the energy released is comparable to a rifle round. The particle vaporizes on contact. It leaves a microscopic crater, invisible to the naked eye, on the outer surface, and it sends a shock wave through the entire structure. To the crew inside, this shock wave is a sharp knock, sometimes louder, sometimes just a sense that the ship shifted slightly, the way a house settles on a cold night. Orion is built to absorb these. The hull has layers of protective shielding designed specifically to break up incoming particles. Engineers calculate the statistical probability of impacts before every mission. A few small hits over 10 days are not just possible. They are guaranteed. The question, every time, is whether this particular hit is one you can ignore. You usually do not find out for certain until the capsule lands and they inspect the hull. The third answer is the most mundane and in some ways the most interesting: the ship itself. Inside the walls of Orion run pipes and pumps and valves and gyroscopes and cooling systems and reaction wheels and propellant lines, all of them operating on automated schedules that the crew cannot monitor in real time. A valve clicking open in the service module attached to the back of the capsule transmits a vibration through the structural connection into the pressurized crew section. To the person trying to sleep, that vibration arrives as a knock on the wall from outside, because, in a technical sense, It is from outside. It is from the part of the ship outside the pressurized volume they are sitting in. The engineers will tell you all three explanations. They will not tell you which one explains the specific knock at the specific moment. Nobody can, not with certainty, not after the fact. The sounds are not the problem. The sounds are manageable. The problem is what they do to a person over time. NASA knows this. Every major space agency knows this. They run analog missions specifically to study it. They put crews inside sealed metal habitats in the desert, in Antarctica, at the bottom of the ocean. They cut off outside communication. They simulate the isolation. And then they watch. The findings are consistent. Sleep quality drops. Trust between crew members erodes. Small sounds that are easy to ignore on day 1 become impossible to ignore on day 40. The crews who perform best are the ones who name the sounds out loud. That was a thermal pop. That was a valve. I heard it too. Write it down. The crews who perform worst are the ones who say nothing, who hear something in the dark and lie still and do not mention it at breakfast. Because silence about a sound is not the same as not hearing it. It is worse. Now think about Mars. A trip to Mars is not 10 days. It is 8 months out, a year or more on the surface, 8 months back. Every thermal pop, every micrometeoroid tap, every unexplained click in the wall, heard 1,000 times in the dark by people who cannot turn around, by people who, if something is actually wrong, have no one who can reach them for years. This is why mission planners study the Artemis II knocking, not because it was dangerous, because of what comes next. The Artemis II crew came home. The capsule is being inspected. Every crater on its hull will be photographed and measured. Every anomaly from the flight logs will be cross-referenced against the telemetry. Somewhere in those logs, on some specific day between Flight Day 3 and Flight Day 10, there is an entry. Crew reported unexplained acoustic event. Source, unknown. Investigation, ongoing. This is what the history of human spaceflight looks like from the inside. Not the photographs, not the speeches, not the flags planted in the dust. This. 4 people in a metal capsule the size of a minivan, farther from Earth than any human had been in 50 years, learning for the first time what every astronaut before them already knew. The ship talks. You cannot always understand it. You learn to live with not understanding. Yang Liwei called his knocking a normal phenomenon. The Apollo 10 crew laughed about their ghost music for the rest of their lives. The Artemis II crew will probably do the same. They will sit on talk show couches and answer questions about the lunar flyby and the Earth hanging in the window and the moment they cross the distance record that Apollo 13 had held since 1970. And the knocking will be somewhere in the back of their minds. The 3 seconds when the training said one thing and the body said another. Space is not silent. The vacuum outside is. But the ship between you and the vacuum is not. And when it speaks, in the dark, at a distance where no one can reach you, you have no choice but to listen.